Hello everyone. I want to talk about what C is. I keep putting plus C at the end of every antiderivative, but not really going into what it is. So I want to think about that for a minute. So if we started off with a derivative of 21x to the 6, and we did the antiderivative on this, so say we found the antiderivative of f prime of x. That should land us at f of x, right? We're going in the opposite direction. Okay, another thing that I want you to know, when you put the antiderivative on the derivative, they cancel each other out. These are opposites of each other. Let me zoom on that so that you can see what I'm talking about. Okay, so again, the antiderivative will cancel the derivative and just leave you with f of x. Okay, so please remember that going forward. Okay, according to the process of taking the antiderivative, and I'll put it over here, if we were to do the antiderivative of 21x to the 6th power dx, then this would mean that we would take the 21 out and we would do x to the 7th power, because that's 6 plus 1 divided by 7, or we would get to 3x to the 7th plus c. Okay, so if this is our derivative, then the antiderivative of that would be 3x to the 7th plus c. So then the question is, what could c be? So I said in these notes, and you guys should have a copy of this, so please take a look at it and have it in front of you as we're going along. Could c be 1? C equals 1, right? So all I've done is I plugged 1 in for this. So let's remember what we said. There's the derivative if this is the original function f. Okay, so what happens if I put 1 in here? If I go this way and take the derivative, will I get that? So let's think. The derivative of 3x to the 7 is 21x to the 6 plus 0. So look at what we said. Look, that lines up with this derivative. So sure, c could be 1. So then here, for this next one I said, well, could c equal negative 9? Right? So all I've done is I've gone here and I plugged negative 9 in there. And let's see. If I take my derivative, what happens? This will be 21x to the 6th power minus 0. So look closely at what our derivative was here. So sure, c could be negative 9, because the derivative of your c term is just going to be 0. And then I asked you, could c be 1,234,567? What would happen when I take the derivative? Should be to the 6th, so please correct that. 7th rather. It's a little hard to read. So this is 21x to the 6th power plus 0, right? Okay, which if you go up here, you'll notice I still get my derivative of 21x to the 6th power. So then the question is, what's c? C could be 1, or C could be negative 9, or C could be 1,234,567. What this tells us is C could be anything. Right? C could be pi for all we know, approximately 3.14. So what ends up happening is, because c could be absolutely anything, 1, 4, 9, 7, 16, 24, negative 8, negative 15, negative 72, then what happens is when we find our antiderivative, every single time you find your antiderivative, you don't get just one function, you get an infinite number of possibilities, right? Because your c value right here, it could be anything. So it gives you a class of solutions instead of a single solution. And let me show you what that looks like. I'm going to show you on my calculator. I'm sorry, not my calculator, but my computer. Let's see if I can turn this so you can see it. Okay. So what you'll notice on my computer is that I have graphed a variety of functions. 3x to the 7th plus 1, 3x to the 7 minus 9, 3x to the 7th minus 2, 3x to the 7 plus 5. Okay, and if you look over here, what it does is it creates a system of solutions that are what I like to call them parallel to each other. Parallel is not the greatest word, but it does give you a visual that it kind of sticks in your mind. They're non-overlapping. That's the point that I'm trying to make. So basically, you're taking this function and you're just shifting it up and down the y-axis, creating an infinite number of solutions, right? C could be absolutely anything, right? In this case, C equals 1. In this case, C equals -2. Here, C equals -9. Here, C equals 5. All of those work for our derivative, which is 21x to the 6th power. All right, so then the question is, how do you find C, right? If you have an infinite number of possibilities for C, then how do you find C? So let me throw something out into the universe, and that is that I need one more piece of information. So if I get an infinite number of possibilities, if I tell you that C goes through this point right here where my pen is, if they're non-overlapping and parallel to each other, only one of the possibilities can go through the point that I just described. I'll say that again. If they're non-overlapping, right, they're parallel to each other, only one of them can go through the point that I give you. Only one, not more than one. All right, I'll get to that in the next video.